Hello. Today we're going to talk about graphing polynomial functions. All right. Polynomial functions meaning higher degree than a parabola. So we're talking like your cubics. We're talking about your fourth degree, fifth degree. Honestly, it comes down to this. Make a table. Make a table of points. Well, how do I know what points to pick? Here's the idea. Start with 0. Start with x equals 0. This is going to be the fastest, easier point to find. Then pick points to the left and pick points to the right. And find points. Solve for y until you notice that y all of a sudden gets off your graph. It grows just crazy fast. It's not even close to all the other values. You'll also notice, hey, maybe it already has the maximum amount of turns. That's how I know I can quit picking points, because my arrows are just going to go up from there. So, graphing polynomial functions. Pick your points, put them in the equation, make a table, plot them, and connect the dots. All right, so after making the table, we're going to talk about the location principle. Because a lot of times what's important, what we want to know is what are the zeros. Now the zeros, or specifically when y is 0, that's when it crosses the x-axis. So we're going to be looking for these points right here. Where does it cross that x-axis? Now sometimes it's not going to cross on nice, beautiful, perfect numbers. Sometimes it will. Most of the times, real world, it's just not going to. It's going to be some in between two values. Now, you're not going to be doing what a graphing calculator does and computing decimal points. You're pretty much going to stick with integers, nice values that work out cleanly and quickly just to get a sketch of what the graph looks like. So we're going to find out that our zeros are in between two values. So you can tell where the values are even before we graph this thing. And they say, if you notice that one of your points right here, this point is a negative, I got a negative y, and then in the very next integer over, I got a positive y, that means that zero's got to be somewhere in between. That's what the location principle is telling you about. So here's an example. If I have the location principle, and look at that, they give me this big old fun f of x equals x cubed minus 5x squared plus 3x plus 2. Wow, okay. At least they did the table for me. They gave me a graph. I can see it. I can tell just by looking at this table where the change of signs are. Notice here it goes from a -7 to a +2. That means there's a 0. There's a 0 in between x equals -1 and 0. So when we talk about where these are, we're usually talking, what is my x? So the f of x is the y. That's how high and low it is. But where does it hit that 0? Where does y equal 0? That's going to be in regards to x. So we're going to be talking about x's in all these. So you notice the change of signs in the y's. It's between the x's that our solution is going to be. So it's in between. It's -0.5 somewhere. Maybe, I don't know. Maybe -0.4. Maybe it's irrational. But that's what we're looking for. We're looking for the change of sign. So I notice a -7 to a +2, then a +1, then back to -4. So there's another change of signs here. That means there's another 0 somewhere in between 1 and 2. So we've got a 0 between -1 and 0. We got another 0 between 1 and 2. And then -7, -2. Oh, +17. Do you notice how it just grew like crazy all of a sudden? So another change in the sides somewhere in here. And I'm guessing it's a lot closer to 4 than it will be 5. So there are 3 zeros. Now, if we look at the graph, notice that we've got a 0 in between 0 and -1. It, again, crosses the axis between 1 and 2. It crosses the x-axis again in between 4 and 5. So that is the location principle. So that helps you know, okay, well, as I have these points, and what is the look of it, it should graph like that. Now, the other thing you're going to want to look at is your lead coefficient. Your lead coefficient right here in front of it, if it's positive, think of it like a positive slope. especially if it's an odd degree, that means it's going to go up to the right and down to the left. If it's going up to the left and you have a positive coefficient, keep picking more points because it's got to come back down. So those are things that you're going to need to look at. The next thing we're going to talk about is maximums and minimum points. Now, that's not official maximum of the entire graph because these arrows go up forever. And they go to infinity, and you can never get to infinity. So there's really no maximum. But relatively speaking, between, say, 0 and maybe 5, in between those 2 points, there is a relative maximum for that interval. There's a relative max. And so what we're going to be looking for is where does these turn? Where does the graph make a turn? Okay, relative maximum and relative minimums are where your graph turns. So to find that, again, we're going to be paying attention to all my points. If they keep going down, keep going down, keep going down, and then all of a sudden they start coming back up again, you know there was a relative minimum. Likewise, if it's going up, going up, going up, and then all of a sudden it comes down again, relative maximum. So you're going to pay close attention to that. So as I look at a graph, I'm going to be looking for trends. So I'm not looking for where's the cross negative to positive. I'm looking for trends. I'm looking right here, starting with a negative 15, then it jumps up to a positive 1, then it jumps up to a 5. Notice it's still going up, and then it goes down to a 3. At this point in between 5 and 3, the biggest number is this 5. This is your relative maximum. Now, it may not be the exact relative maximum, but it is a good estimation of our relative maximum. And for today, we're just going to be worried about those integers, those nice whole numbers. So then we're going to go back and start it over again. I'm at 5. I'm going down to 3. I'm going down to 1. I'm going, whoa, back up to 5. This is my relative minimum. It's the smallest one of, it's a 3 on one side, it's a 5 on the other. That's my relative minimum. So that's what we're looking for in a table. But again, this all comes back to your table. And that's it. You pick points, you find where the turns are. You should know the general shape just by looking at the equation. What? Remember last section? It was all about the lead coefficient and the degree. If it's odd degree, the ends are going the opposite direction. If the lead coefficient's positive, it's like a positive slope. It's going to look something like this. And you can tell by the graph that they gave us, it does. So have this in your mind ahead of time when you graph this to know what your graph should look like. Let's do an example just to get you going. Most of the time is going to be spent finding your points. It just is what it is. But graphing it will go okay. So here's my recommendation. Start at 0. Now, don't be thinking 2 points is enough or 3 points is enough. It is not. You need to pick a lot of points. We're talking anywhere from 5 to 10 points. So plug in a 0. I love starting with 0 because 0 cubed, 0 squared, doesn't matter if you multiply anything, it's always 0. So really, when you plug 0, it's this C number. It's your last term is your y-intercept. So when I'm 0 left and right, I'm going up 1. That's my y-intercept. I could even plot that on the graph right here. Next, I like going positives first. So let's put this in an equation again. Let's put in that 1 for x. 1 cubed is a 1, minus 1, and plus 1. So we're looking at another 1. Kind of weird, but okay. Just keep finding it. We're just going to keep on going. Let's try a 2. 2 in the x spots. 2 cubed is an 8, minus 4 plus 1. We're looking at 5. All right, so the point 2, 5. Let's try another one. 3. And we're just going to keep going on this. So when I plug in a 3, 3 cubed is 27, minus 9 plus 1. Isn't that all equal 19? Wait, 19? Yeah, crazy. 19. Okay, that went up fast. So notice as I plot these points, this 319 is off my graph. I don't have that many points. I've got an over 1, up 1. I've got a 2 up, 1, 2, 3, 4, 5, and then as I'm at 3, I'm way the heck somewhere up here. I don't know, but it's growing super fast. So I know that from this point to this point to the next point, I can't cross that 3 line until I hit 19. Okay, I'm thinking I know what it's going to do. Did you notice it's a positive 1 leading coefficient? That means it's going to go up as I go to the right. So that's my arrow. But it's a cubic. It might have up to 2 turns, maybe. So we're going to have to keep picking points until we find it traveling down. So now where's it going? Let's start with the negative side of things. Let's start with a negative 1. Okay. So grab my same equation. Let's go negative. Be careful with this, though, because if I go negative 1, negative 1, negative 1 cubed is inside parentheses. That stays a negative 1. This negative 1 squared is a positive 1, so you're going to have a minus positive 1 plus 1. So then we end up with another negative, or this is a negative 1. Okay. Negative 2. Let's do it again. Just keep grabbing that same equation. Plug in negative 2. Whoops. And we're at a negative 8 minus a positive 4 plus 1. We're looking at a negative 11. Now, this is off my graph. The question is, do I need to put in a negative 3 or not? When in doubt, test it. Let's keep looking at this. So I've got a negative 1 down 1. Okay, that's good. And then I've got a negative 2, 11. That's like way down here. So as I graph this, what should this look like? Well, I've got a few points. I know it's going down here, and it's going to come up to this point. Then it has to connect up with my y-intercept, but it's got to make some turns. And being that these two are on the same level, it's going to have to come up, come down, and change directions again. And then it'll go up. It's a very small turns, but do you see the 2 turns? So relative maximum would be this point. Relative minimum is in between them because at 0 and at 1, they're the same. Relative minimum is in between. And I'm not for sure, but it looks like there's only one 0 at about x equals negative half or so. So that's the idea. Pick a lot of points. If you wanted to put in the minus 3 just to find out, go for it. Just keep plugging these things in. Negative 3 ends up equaling a negative 35. Holy cow. So you see it never comes back up. It's got its 2 turns. It can't have any more. It's only a cubic. A lot you can tell just from the equation. Think about the equation. Think about what it should look like ahead of time. Good luck. Happy graphing.